Differential equations, type 1, first order. 2008 question 10a had the equation x squared y dy dx plus y dy dx is equal to 1. And we were told that when y is equal to 0, when x is equal to 0, then find the value of x when y is equal to root pi over 2. So we're going to start by getting our dy on the left and our dx on the right. So we're separating out our equation. We're going to take out dy dx as being common. And we can also take out y as being common, which leaves us with x squared plus 1 is equal to 1. And therefore, if I divide across by x squared plus 1 and multiply across by dx, we've now separated out the y's and the x's. So we're going to then integrate both sides. We're going to integrate the left with respect to y and integrate the right with respect to x. So we have to set up our limits. So at the start, we know that x is equal to 0 when y is equal to 0. And at the end, we're looking for what is x when y is equal to root pi over 2. So our upper limit are our end limits. And now we're ready to integrate. So on the left-hand side, if I integrate y with respect to y, that means I'll add 1 to the power, divide by the new power. And on the right-hand side, we have to identify that this is 1 over something squared plus something squared. So if we look up here on page 26 in our maths tables, we can see that that's going to be tan inverse. So in other words, a is going to be equal to 1. So we have 1 over x squared plus 1 squared. So therefore, integrating that is going to give me 1 over 1 tan inverse of x over 1. And that's what's in the limits of x and 0. So if I put in my limits, I have root pi over 2 squared over 2 minus 0. And then subbing in for tan inverse of x minus tan inverse of 0. So if I square the square root of pi over 2, then that's just going to be pi over 2, which is pi over 4. And that's equal to tan inverse of x. And tan inverse of 0 is 0. So then that means that x must equal tan of pi over 4. And therefore x is equal to 1. So we had 5 for setting up our equation, 5 for integrating correctly, 5 for getting our tan inverse on its own, so subbing in our limits. Sorry, I shouldn't say pi. I should say 5. And then 5 for the answer.